Welcome back. In this video, we're going to continue on talking about section 2.3, which is lines. Okay. So we found the slope of a line going through 2 points, okay, using those 2 points in the last video. We can also graph the lines made by these points on the same coordinate system, or that's what I want us to do. And so, really, I sort of did this in the last video, but we're going to do this now with a better XY plane here. And we'll illustrate how each of those lines look. Okay? So 1, 2, a point, again, as I said in the last video, a line, sorry, not a point, a line only needs, we need 2 points. Okay? 2 points need to make up a line if I don't know the slope. So first line, line 1, I'll do in red. And so the points are 1, 2, and 5, negative 3. 1, 2, 3. There. And so the line that goes between those points looks something like that. And so you'll see, if I go back here, that the slope of that line was negative. Okay, this one was negative 5/4. So if we look over here, we see that if the slope is negative, the general pattern of this line is going down and to the left. Down and to the right. Okay, so that's what a negative slope looks like. Now let's look what a horizontal line looks like. Okay, 2, 3, and 5, 3. We'll do this one in blue. So if I go over 2, 3 is the point, x is 2, y is 3. Okay, so 2, 3, and 5, 3. Okay, and again, it is the line that goes through those 2 points and looks like this. Okay, that's a horizontal line, slope of 0. Okay, it doesn't go up or down, it just keeps on going in the same y direction, or in the same y value for all different x values. Okay, so that's, I don't know, I'll say steady for that one. Okay, and then 2, 3, and 2, 5. We'll do that one in green. Okay, 2, 3, and 2, 5. That makes a vertical line. Okay, that is vertical at 2. Okay, we would define, so it's important how we would show this as an equation, and we'll get to the other ones later, but the equation for a horizontal line is y equals some number. Okay, y equals 3. So that's saying on the y-axis, the line is at 3 the whole time. Okay. For a vertical line, it shows us here, we would write this as x equals 2 because we're on the x-axis and x stays 2 the whole time, no matter what y value I have. Okay, so those are 2 important things to keep in mind for horizontal and vertical lines. Okay, and of course, if the slope is positive, we'll say purple. If I had 2 points that were here and here, a positive line goes up and to the right. Up and to the right. Okay? So that's the graph of a line using 2 points. Now, there are a number of other ways that we can graph a line and sort of show or describe a line, and one of them is given a point and the slope. Okay, so before we were working with 2 points and we could find a line. We can also work with 1 point and the slope. Okay, so we start with a point and then use the definition of slope to make that line. So for instance, we have the point 3, 2 and a slope of 1/2. Okay, so we start with the point 3, 2 here. Okay, and then the trick is we need to use the definition of slope that we talked about last time to show where the line goes. And so I said that the slope was the change in y divided by the change in x. Okay, and also we will often reference this, and you may have heard of this before, as the change in y is called the rise, and the change in x is often called the run. Okay, and so that's a helpful sort of mnemonic that tells us what each of these numbers in the fraction are doing. Okay, so I'm going to start, so slope of 1/2 means I start at the point that I have, 3, 2, and I rise 1, so I'll change to blue to do the movement. It says I rise 1 and I run 2. Okay, so I rise 1 unit and then I run to the right 2. Okay, so positive is always either up and right, negative is down or left. Okay, positive is up or right, negative is down or left. So if I rose 1 and ran 2, then the new point that I get is right here. Okay, and of course we don't want or need that blue. We just need those points. Okay, so there's rise 1 and run 2. Now I have 2 points which define a line. Okay, so I can go that way. But to get a better line, maybe I want some more points. So I can continue. I could rise 1 here and then run 2 this direction and get to that point. And I can also go in the opposite direction. So slope of positive 1/2, I could rewrite that as -1 divided by -2. Because the negatives would cancel out and I'd leave with positive slope. So I could, in theory, go down 1 and to the left 2, down 1 and to the left 2, down 1 and to the left 2 again, and that is going to get me, that strategy is going to get me more points on that same line. Okay, so there is the line, point with a point and slope. Okay, using this rise over run approach, which we'll use quite often. Okay, so for instance, here is an example with 3, 2 again. 3, 2, but now I have a slope of -1/2. And so from our intuition before, it says that with a negative slope, I'm going to have a line that goes down and to the right. Okay, that's what I should be looking for. And so I have a slope of -1/2, and I could rewrite that as -1 over 2 or 1 over -2. Okay, either way I'm going down and to the right. So I could have, let's go with this one first. Okay, -1 means a rise of -1 and then a run of +2, which gets me there. Okay, so I get these 2 points and create a line. I could again go down 1 and to the right 2. Or, using the second one, I could go up 1 and to the left 2. Up 1 and to the left 2 gets me there. And then there, 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 and all the way up to there. And so when I draw a line through those points, okay, that's going to give me, the line. Okay, so that's a graph given the point and the slope. So that gets us to point-slope form. We can use the point and the slope to form the equation of a line. Okay, so this is point-slope form. Okay, y minus y1 equals the slope times x minus x1. Okay, so what we have is a slope and 1 point. Okay, only 1 point. The y, what's important to remember here is this y is a variable, not an actual number. This one, so it stays as a y. And this x, again, is a variable, not a number, so it stays x. So to find the point-slope form of an equation of a line, all we have to do is substitute in m, x1, and y1. Okay, so let's do that. So I'm going to find the point-slope form of a line with 1, 2, and a slope of 4. So what I do is say y minus y1, which is the y value of the function, 2 equals the slope, 4, times x minus x1, which is 1. Okay, and then that is the answer. Okay, so it is that simple. All you have to do is substitute the values in to this equation. This equation right here. So, for your turn and the end of this video, I want you to use this point and the slope, 1, 2, and slope of 3, to find the equation of the line in point-slope form.